Welcome, 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 everybody. First of all, thank you so much for being here. But let's jump into the episode 5 of Rising Stars in Ophthalmology, where we're today going to be talking about an extremely important and pivotal topic, digital ophthalmology. It's known to a very few of us and unknown to a lot of us. So there's a lot to learn from this episode. But before we do this, let me explain to you how all of this works. Each episode will feature one rising stars and surround them with 3 celebrity panelists. And these celebrities are not followed by PAPs, but they're followed by all of us who are following them for years together, and we look up to them as mentors in this field of ophthalmology. This is a very interactive discussion. So any audience member watching out there can always send in their questions on the YouTube chat window, and we will, as moderators, pass it on to the panelists and the speaker. We're live on website risingistars.com and our YouTube channel Rising Stars in Ophthalmology. The reruns can obviously be watched on our website. Also, watch out for our social media, Facebook, Twitter, LinkedIn, Instagram, where we release educational tips and snippets from all our episodes. At the end, I'd like to thank all of you first of all, for tuning in, and thank the sponsors for making this happen. Now, to do the honors of introducing the panel and the speaker for the day, can I please hand over to Jennifer Lowe, who's my co-moderator, and I could not have done this without her. So to introduce the speakers and panelists. Jen, all over.
Thank you so much, Ashwin. It's once again a great honor and pleasure to be able to co-moderate with you and to introduce our great panelists and our rising star. First, I would like to thank our season sponsors, without which it would be impossible for us to run this program. So thank you to our season 3 sponsors, including Allergan, Alcon, Visus Therapeutics, Dompe, Avellino, Young MD Connect, Sun Ophthalmics, and Tarsus. Once again, thank you for your sponsorship. Next, I would like to share my screen and bring up a PowerPoint showcasing our episode, as well as discussing our rising stars and celebrities. So first, our first amazing panelist is Dr. Sean Ianchulev, who has an MD and a Master's of Public Health. He did medical school at Harvard, Master's of Public Health also at Harvard, residency at the Doheny Eye Institute, fellowship in glaucoma at the Doheny Eye Institute, and he's currently a managing partner of PME Ventures, professor of ophthalmology at New York Eye and Ear, and director of technology and innovations at the New York Eye and Ear Mount Sinai. Fun facts: he is the inventor of intraoperative biometry that we all use, or many of us use, and most of us know about. He also is the inventor of one of the my favorite devices, the MyLoop, and he's currently working on a new ocular therapeutics, which includes a piezo print optojet, which I think will help revolutionize the way that medications are delivered. Fun fact that Dr. Ianchulev said, he quotes, "I like non-linear pathways. At the age of 19, I ran away from communist Bulgaria all the way back to the US, where I met and then married my wife, who lived in the same neighborhood back home," which I think is really, really cute. And I can't wait to hear more about that. So next up, we have Dr. Kuldev Singh. He did college at McGill University, medical school at Johns Hopkins. Also, he did a Master's of Public Health as well. So we have 2 people here with an MPH, residency at Oregon Health and Science, fellowship of glaucoma, Bascom Palmer, and currently he is a professor of ophthalmology at Stanford. Now, his fun fact is that despite having minimal knowledge of opera, he's been to 3 tenor concerts and dined with Pavarotti in Paris. And that must be an amazing story. Hopefully we have time to discuss that as well, Kuldev. Next up, Dr. Kathryn Hatch. She went to college at Middlebury College, medical school at the University of Vermont, residency at the New York University of Manhattan Eye and Ear, Nose and Throat Hospital, a fellowship with the cornea and external disease. Fellowship in corneal and external diseases at Mass Eye and Ear. And she's currently the director of refractive surgery at Mass Eye and Ear, and she directs the anterior segment fellowship also at Mass Eye and Ear. Her fun fact, she's developing a mass screening device for keratoconus. And all of us who know her know that she loves running, especially short distances, chasing after her kids and up to marathon distance. So Dr. Hatch is an amazing runner. Okay, so now that we've touched just briefly on our amazing celebrities, and that again, that's just touching on to just the tip of the iceberg on all their accomplishments. I did want to spend a few minutes talking about our rising star for episode 5 and introduce to you Dr. Eric Rosenberg. He did college at Lehigh University. He did a master's in engineering, I think, at University of Pennsylvania. Is that a master's, Eric? Okay, I didn't know what MSc was. Medical school in New York. Residency at New York Medical College, fellowship at Cornell, and he's currently the director of clinical technology at Site MD and associate professor of ophthalmology at New York Medical College in Northwell. He did help design and engineer tactile feedback that's found on the Da Vinci surgical robot. So that's amazing. And hopefully you'll share a few pearls with us tonight. All right. Also, we did include, or you provided for us, some fun photos if you'd like to take a few minutes as our rising star to explain what these are.
Oh, man. This was a little bit about fellowship and residency here. The first one was actually getting the golden apple at ASCRS, which was definitely a highlight of my career so far, doing the complex and challenging cases, which I do enjoy doing. My beautiful bride, Dr. Alana Naddis, who really I just hide behind, and she does all the heavy lifting. So most of you know her, and I usually go by Alana's husband, which is A-OK in my book. We have in the top there a combined retina and cornea case with Dr. Miko, who heads ophthalmology at Weill Cornell, and Kimberly Sippel, who helps direct the cornea program. Just below it was actually our graduation. We tried to have a celebratory lunch in the park, and there was a flash flood. So it turned into a little bit of a swimming adventure and some other activities I like doing on either side there.
Nice. Okay. I think I have another round of pictures here.
Yeah, just again, some fun we've had. The bottom left was actually one of the first times that Ingenuity was used in anterior segment surgery. Robert Weinstock was, a very big proponent of it, and I think we were next in line doing a lot of our cataract and cornea procedures with it when I started up there. Next to that is the president of ESCRS, Oliver Findel. I was invited to Austria along with my wife to go to his operating theater, and we enjoyed learning new techniques. And it's the reason I do all my blocks via subtenons, is learning that technique from Dr. Findel and some of the ways he approaches posterior segment work. I copied him a little bit there. He's a really brilliant mind. Above, we have Stegman and Donnefeld, obviously huge people in ophthalmology, inventor of viscoelastic, and Inder Singh, one of my personal favorite, thumbs up on an airplane with him. And my wife and I going out to dinner at one of these meetings, and the table being right there on the beach, which was really kind of cool and surprising when the tide came in.
That's funny. She looks surprised.
I surprised her in many ways.
Yeah. And I think there's, last but not least, I think there's a few more.
My favorite, absolute favorite slide. The first picture on the left was actually our first case together as attendings, as cornea specialists. This was a cataract, but we wound up doing a couple corneas together that day. On the way right is when I really get under her skin, she threatens me with the 27 gauge BSS cannula, and she's vicious with it. But right down the middle is our pride and joy. It's Amalia. She just turned 1 this past month. And it's really been a learning adventure from the get-go. And she's our greatest production to date. So we had to include her, and the dog enjoying the Thanksgiving turkey. Yeah.
Oh, good. Well, thank you so much for sharing a bit about your personal life. And I can't believe she's already a year old.
Oh, time's flying.
Yeah. Well, I'll let you share your screen now so you can start off with your presentation.
Absolutely. Let's move some of this. So, I think first I'd be amiss to not thank, Ash and Jen and Bill for having me here today, and being the visionaries you guys always are in order to have this, and constantly building out and making our field a better place than it was yesterday. So we're eternally thankful for myself, and I'm sure all the rising stars feel the same, and the panelists. I'm also extremely thankful to always be learning from you guys, and I do that on the daily, and appreciate the opportunity to convey that as well through this platform. So I want to wish everyone at home too happy holidays, and hopefully you had a great Thanksgiving, and hopefully a better Thanksgiving than my dog did, because that's really setting the bar high. And I sincerely appreciate the team here for identifying that this area of ophthalmology is quickly growing and will require a significant amount of time and attention as the years proceed in order to build a sustainable future that works for the future generations. I'd also like to point out that they did a phenomenal job with picking out the 3 moderators who've all moved the needle in this arena. So with that said, I'd like to introduce you to digital ophthalmology, the wild, the weird, and the wonderful. So before anybody watching thinks I jumped right in and went for the red pill, I'd like to first provide some context and review a little bit about the evolution in personal computing and draw some analogies between user experiences. Welcome to Microsoft MS-DOS version 1.01, circa 1981. It was a truly revolutionary product that set the stage for all true innovations that followed. The next iteration followed suit. So to the left, we have version 2.0, and my personal favorite 3.0 with the advent of Minesweeper. I can personally attest to nothing killing a few hours like Minesweeper. I had the opportunity to play it the other day too, and man, it's addicting still to this day. So not far behind, and yet another major step towards modern day computing was Windows 95. We had a true desktop, right? The internet was vastly more broad, email just beginning to gain traction, and organization tools and software packages with easier access were all formulated. The personal computer was really starting to take form here, and the capacity and breadth of functionality making itself more known to the general public. It's here that I'd like to propose that ophthalmology is akin to Windows 95. We have new useful tools for helping us make diagnoses easier than in generations past. That's unquestionable. We have a mandated central EHR hub for accumulating data. And like the early operating softwares, very difficult to deal with at times. And lastly, there are several processes which require heavy user involvement in effort to return data back to the user or us. So akin to Windows 95, there's a litany of tasks that we want to perform. And given the breadth of territory, we've become vastly overburdened and ironically slowed by that same technology that's advancing our field. So now how do we bring ophthalmology to this point right here? This is Windows 10. It's a seamless user experience with most everything available at the click of a button. You have autofill functions for your credit cards, automatic connectivity to your wireless accessories, intelligent algorithms that can predict what you are going to pull up even before you do. So ironically, it all stems from that same black box in the middle of the screen. It's a command prompt, coded, designed, ever running. The command prompt has been in existence since version 1.0, and it remains to this day. The only thing that's changed about it is how we approach it. So occasionally, in order to go forward, we need to go backwards and break down some of the new technologies and understand their applicability. So first, let's chat a little bit about the wild, and that's going to be machine learning. More recently, I heard a new term that I like over artificial intelligence, and that's augmented intelligence. We're not at a point yet where machines or software packages are making our decisions for us, but rather augmenting our capabilities. So I believe I owe this term to Yannick Leiderman or Ted Lang. I can't remember who it was, but it was a really brilliant observation. So I tried to illustrate a good way to think about this for the routine cataract surgeon. To the left, we have the traditional mechanism for selecting patient IOLs. To the right, we have a model for machine learning of the same task. An important point to consider is that we are constantly flooded with information. And using clinical judgment, we do our best at weeding out pertinent from non-pertinent information as it pertains to the function at hand. So does the patient have a short eye? Well, okay, that changes the IOL algorithm that I'd prefer to look at. Does the patient have Fuchs? If yes, is there high likelihood that that same patient's going to need a DMEC following the cataract procedure? If yes, again, then the refractive target I'm going to wish to pursue is going to change. Does the patient have a history of LASIK? Okay. Then let's hedge our IOL selection on a various set of other diagnostic instrumentation. The list goes on, with most information gleaned from studies and or supplemental adages from our preceptors. By employing self-learning algorithms, we will and we may be able to process significantly more conditional statements and parameters, some of which we may not even appreciate now as being relevant. So in reality, neural networks and machine learning look something like this. This is a slide compliments of Rania Habash. In its simplest form, it's a model of inputs, weights, biases, and outputs, just like us. While trying to avoid getting granular, incorporating AI and machine learning into daily life is going to have several advantages. Number one, it's going to eliminate human biases. Two, we'll be able to aggregate and weigh a significant amount of information. And three, we'll be able to process big data and create large databases in which to pull other information from. It's also important when you bring up advantages to note the disadvantages. And as we move forward in time, they're going to need attention. And some of those disadvantages are data biases, which are going to be up to us as the code writers to identify and eliminate. Metadata and the wide-scale adoption of ubiquitous headers and subheaders for the information to reside, which is something we're having problems with right now in DICOM servers. And ultimately, the interoperability and interconnectivity between these systems, the data and the metadata going forward in time. So here's a snapshot taken from Yannick's intraoperative AI software that can in real time identify what steps of the cataract surgery are currently being performed. So here we see the software identifying that we're at the capsulorhexis stage, and it digitally provides a 5mm guide to help you create that rhexis. Now, you may be thinking to yourself, why do computers need to know in real time what parts of the cataract surgery are being done while they're being performed? Especially because, well, you know what step is being performed. But that question, we're going to get back to in a little bit. So this brings me to my first question for Kuldev. Where have you best seen the incorporation of AI into ophthalmology to date?
I was going to ask you that question because I really don't know the answer to that question. I've been hearing Pierce Keen talk about AI every year at a meeting I organize, or not every year, but commonly. And I'm still trying to figure out where AI can help us right now, or where it's already helped us and we don't know it yet. And AI is no longer a new concept. So AI has been around for a while now, and I think it's time for AI to deliver. So I'm going to throw this question back at you and ask you: is there something we're doing better in terms of patient care now because of AI? And I only want one example, because that will make me a believer. If you can show me one example of where AI has made a real difference in outcomes.
So it's a great it's a great toss back, and you're right. It hasn't made its debut in prime time for the most part, and there's only really one or two platforms that have cleared the FDA in terms of being able to be used, and that's in diabetic retinopathy.
So just to clarify, it was really actually an honest question. It wasn't really a statement. So I wasn't really making a statement that AI has not delivered. It was really like a legitimate question regarding because I'm not, you know more about this field than I do. is there something, if someone comes to us and says, hey, why should I invest in AI? Is there an example that you can give them and say, hey, this people are seeing better, or people are seeing longer, or people are, or we're able to treat more people effectively, and here's the data to prove it, and the reason for that is AI. So I'm actually going to throw that back at you to give me that one example.
So that's a great point. Large scale data sets I have not seen, but small data sets, and especially in community settings where there's a lack of access to care, I think is a really important implication and application of AI and screening devices, right? What we do know is that there's going to be a shortage of ophthalmologists going into the next 20 years. That's not really up for debate. We know that as a fact. And the number of ophthalmologists is not going to be on par with the number of patients that need care. And you're going to find areas that are underserved becoming even more so underserved. So we have one of two options as it relates to things like that, right? We can either start training or attempting to train people who are not necessarily qualified to be able to do screenings or diagnostics. Alternatively, we can start designing technologies in order to take care of a larger number of patients. And Ted has a really great talk on this and the utilization of AI for diabetic retinopathy screening. And so does Hovhanessian, actually, where they were using it in Armenia to be able to do large scale screening. But in order to use the software packages to just screen for patients instead of coming into the clinic and taking up those valuable seats for people who may need intervention, right? That would be a huge advantage of AI if it can aptly screen for, let's say, diabetic retinopathy, or something as complex as glaucoma with due time, right? So I think that there's a very strong argument for the utilization of it. It's the execution, which I think that they're currently working on to find the best way to reach the largest number of people to help.
So I'm just gonna jump in right here because I think the ground rules are this is a conversation. So I'm gonna just ask ask for the distinction between telemedicine and AI, because I totally get remote examination. So not having to have the patient come to your office, but rather be able to do an OCT at home or at some center somewhere, or do an eye pressure measurement, or get a fundus photo somewhere and find out if they have diabetic retinopathy. So to me, that is remote management or remote gathering of data. But then for me, AI is really taking that data and doing something with it, either that is faster and more efficient than what humans could do with that data, or do something better that humans just couldn't do at all without that data, finding some insight on how to treat patients better.
Oh, I agree with that completely. And sometimes those lines are blurred, especially as it relates to ophthalmology, because it is both diagnostic and we were just talking about this prior, is both heavily reliant on imaging and physical examination and human intervention, which is why I like the proposal of augmented intelligence rather than artificial, right? It's helping you to screen, and maybe if you have a large scale set of data or images, even, it would be able to process through them and then flag the ones that may need addressing, so to speak. And then you can use telemedicine in order to intervene. But I think telemedicine is going to be a huge part of what we do in the near future, even though it's not very strongly adopted at the moment.
So Eric, this is Sean. I think probably at the time when Kuldev and I studied MPH, they called it public health. I think today we call it population health. But I think diabetic retinopathy, as you mentioned, is a very good example. Digital Diagnostics and iNook are two companies that kind of opened the field. And we can now reach rates. I think they started with about 85 to 88% sensitivity and specificity. One of the companies that I'm involved with, we developed the technology for DR screening based on autonomous AI. We just got FDA approval about a month ago. We're now at 93%. So things are really getting up there where I think AI is going to get better than us. And frankly, in light of the fact that we're highly trained and few of us, probably doesn't make any sense for us to be spending our time screening for diabetic retinopathy. So going back to public health and population health, I think AI really can help us eliminate this additional work, and where you have to deal with high throughput situations, which is mostly population health and less so medicine. And so that's one of the things I'm very excited about, whether it's telemedicine or virtual care or population health, is really AI helps us do things much faster and have a high throughput in population health. And diabetic retinopathy is one. We're working on a system now with Joe Schumann, the same thing for referable glaucomatous neuropathy, where we can actually diagnose the same way. And probably you can take a picture of the retina and diagnose a lot of things, including stupidity, probably one day. But the bottom line is, I think when you talk about population health and public health, this is where AI can really help us, because we can focus more on intervention rather than really high throughput screening, where 90 to 95% of the time we're dealing with normals.
Yeah, I think that's a great point, Sean. And I do see the great value there in taking like a zero or maybe 2 zeros off of the numbers of people that a doctor has to look at. You know, these diseases that most people don't have, but are still potentially devastating. If you can find ways for AI to first of all, you need the instruments to gather the data, but then if the machines can, with a high degree of sensitivity, so you're not missing anybody, reduce the numbers of people that then doctors have to look at, and have the high degree of specificity as a follow-up to find the people that are treatable. I think that's the greatest value for AI. And it hasn't, I mean, I think it's still early, but I see certainly in diabetic retinopathy, there's tremendous potential. And hopefully for glaucoma too, although in glaucoma, I think we still have to better define what glaucoma is, which is always a limiting factor in moving forward for in glaucoma. But I'd love to hear from Dr. Hatch on this in terms of corneal disease, in terms of if there's any, maybe we should turn it back to Eric, because he's probably got questions for
No, I like the idea.
No, I actually was going to chime in. I actually have a special interest in keratoconus, and I'm actually trying to develop a screening device with Josh Young from NYU that can screen it with using AI actually to screen patients for keratoconus. We have I think a public health issue with children, adolescents who are missing keratoconus, and they're not getting to cornea specialists for cross-linking, till they have very, very advanced disease and are bound to scleral lenses. And, we really should be screening these kids early. And, I think that AI is going to have a huge role in that process. And hopefully we'll be screening for this condition in schools, is my hope, or in pediatricians' offices, not even in the ophthalmology practices. I think we should be mass screening at, every 12, 13-year-old for keratoconus, maybe younger. And so, it's just not possible to do that without some, I think, machine learning, and even just to have a risk stratifier to say that this is a high risk patient, now go to see an ophthalmologist or an eye care professional and get a real topography or tomography and get diagnosed. I think it's a huge role, and it's a public health issue. I mean, keratoconus is a real issue it's actually very common condition. So
how about for repetitive tasks too? So we all touched on the public health issues, but getting rid of some of the repetitive tasks that are in our day-to-day by implementing self-learning algorithms like IOL selection. How would you feel if we start using self-learning algorithms to be able to appreciate post-operative outcomes, especially because it's already being entered into the EMR systems, and making making the system intelligent, so to speak. So maybe we don't have to pick out IOLs. What if we utilize Aura with the preoperative biometry, with previous histories of data sets and based on patient demographics, sex, age? What if these algorithms help us to select the IOL, and we don't? I can tell you myself, I spend hours at home each week picking out the correct lens for my patients because I see everything from routine to the complex. By implementing these AI technologies there, I think that it's going to save me time, personally speaking, as a community ophthalmologist, being able to help treat more patients, if you will.
I can comment on that. I'm sure the others do cataract surgery as well. And I'll comment on that and say that it certainly could. I think we already have, we've already been using AI to an extent to tell us what outcomes we would get with particular lenses. But there is that human component that I think it's hard to remove completely. This knowledge of how bad would it be if somebody became slightly hyperopic. And the issue of, some people just wanting to have a certain refractive area. I mean, the common choices are, of course, distance, near, using whether they want a multifocal or not, whether they want a toric or not. But also there are people who, in our community, there are people who just want to be -1, that just want to be slightly myopic. And so that element, I don't know if the computer or any kind of algorithm will be able to replace the conversation you have with the patient. But I can
said it has to replace it, though. I mean, that is information.
You're not
that's
promising
data.
replacing it. Yeah. No, but I think in many ways it could make it easier. And I think so. Your point is a good one, that it could certainly make the amount of time and effort spent to come to the right conclusion might be reduced by having great data. And I think IOL calculation, if you ask me if there is an area where AI has made a huge difference, and this is going back a number of years, and that is definitely it's IOL calculations where we've used data, we used algorithms. We've had, when LASIK and PRK, when PRK and LASIK came out, people developed algorithms to do phaco on eyes that have had prior refractive surgery. And it's remarkable how well those people do now relative to when we first started doing cataract surgery on those people. So I think that's where I would point to if you ask me that first question again.
Perfect. All right. Thank you, everybody. I love this conversation. I could probably continue it. I'm sure somewhere on my text message, Bill is yelling at me. So I'll keep the show going. So as weird as it is, this is by far my favorite part of this talk. This is about NFTs and the metaverse. So highlighted here is a $10,000 stick figure picture. At first, I couldn't explain it. I really couldn't. Then down the rabbit hole I went, fully understanding and reviewing the mechanics of the Web3 space would likely necessitate its own series of lectures. But it has been a very valuable exercise for me, not just financially, honestly, but helping to understand the bigger picture and how implementation and utilization is going to revolutionize the healthcare space. So let's talk a little bit about what NFTs are. In its simplest form, an NFT, or a non-fungible token, is a non-interchangeable unit of data stored on a blockchain. It's a form of digital ledger that can be sold or traded or soul-bound to the user's wallet. It can be viewed as simple as the NFT being a piece of art, or as complex as a token-gated key, which affords the owner access to a slew of other information. What's undeniable is that the pervasiveness of cryptocurrencies and Web3, as we enter into 2023. So involvement ranges from entire governments like Britain to companies like Fox, NBA, Porsche, NASCAR, Nike, Tiffany's, all the way to high-profile individuals like Kate Moss and Ellen DeGeneres. So the blockchain technology constitutes the foundation for NFTs. And most of all, it creates a method for decentralization, allowing information or transactional records to be stored on public databases. It's really made up of 4 components: a consensus, a provenance, immutability, and finality. So we're beginning to bear witness to methods for improving the security of patient data, offering digital health wallets for patients to retain and provide health records, thereby reducing costs on repeated tests, and having standardized non-subjective histories and interpretations. This is MedDAO. It's a decentralized autonomous organization, also known as a DAO, dedicated to providing unique solutions for credentialing, all the while keeping track of all those certificates that we've accumulated along the way. By leveraging soul-based tokenomics and blockchain technology, we're going to be able to provide the hospital with our wallet to ensure that proper credentialing of everything from privileges to procedures to educational history without ever having to lift a finger. I'm personally still in disbelief that last month I needed to go hunt down a notary for one of my hospital systems and was in awe of the amount of wasted time that went with this futile process. When 90% of the hospital's administration credentialing department becomes repurposed for something more beneficial, I will be glad to be the old man in the back of the room recounting memories of this previous archaic process. It's going to be a pleasure. So now on to my other favorite topic here is the metaverse. Most recently, the Digital Ophthalmic Society, powered by MetaMed, went on to become the first organization in ophthalmic history to host a 60-plus person meeting entirely in the metaverse. With 3D 4K video playback capabilities, we had 3D spatial surround sound, volumetric recording, and first-person avatar control. Platforms such as these are going to allow the users to experience a meeting very much like if they were there in real time. I'm going to play the video for you here. You're going to see that people are walking around. And if you want to talk to somebody, you walk up to them. And the 3D spatial audio allows you to have private conversations like we would, instead of a platform like this, where we're up on stage and you're really just hearing, from us. Move it a little bit forward here. If you're in a headset, you'll be watching this in 3D. Today, he's going to be talking about a software suite for digitally enhanced ophthalmic microsurgery. So, take it away.
Thanks so much, Eric. It's really a privilege to be able to speak at the DOS meeting this evening. This is one of my first episodes in the metaverse, but I think it's so well suited to a lot of the technology we're going to be speaking about tonight.
So I'll turn that on. So walking up to legends in this space like Kathy McCabe, Liz Yu, Ted Lang, and being able to have these private conversations with them without having to leave the comfort of your own home really made the wow factor for me. While it's unlikely to replace live meetings anytime soon, the technology underpinning the platform is indisputable, and it's going to offer up a new method to augment our existing methods of knowledge transfer. So this next question, let's see if we can get it up here, is for Kathy. With anything possible in the metaverse, where would you see the most value in incorporating, these types of technologies? And we can also talk about NFTs and blockchain as well.
Yeah, and this is fascinating. I mean, I don't think I've seen this before. Why leave the house, right? That's really interesting, an interesting concept. I mean, yeah, it's hard to imagine that we would totally lose our in-person meetings. I mean, we obviously have, there's nothing like in-person connections and, some of the interactions that, we have at those meetings, but it is, sometimes just impossible, obviously, to go. And certainly, with COVID and we never know what's going to happen in the future. I mean, it's to be able to have something like this in your home, where you could really continue to make some type of connection with people it seems really exciting. Do you envision like we'd all be like wearing like VR headsets in our kitchens and just hanging out with VR headsets? Or
some of us already are.
Imagine what this would be like. So techie.
Why is John Hovnessian like bending over to like, is he whispering to?
Yeah, but did you notice that he was whispering over to Kathy?
So robotic. Can they look a little more natural? Maybe.
So yes, the avatars are going to be developed a little bit more, but then it actually has a facial recognition feature that it actually can study you blinking, the movement of your mouth, nose, and it can mimic that on the avatar itself. But it's funny because when you're in that space, if you get too close to somebody, it's like you got too close to them in real life. You back up off of them, because it's a very immersive experience, going through it. And you're right. I think that it's really hard to go to all these meetings, and we found it very difficult, especially with our newborn. And Alana used to go give a bunch of talks, and she's rising star for Al, and now it's a tough decision, right? Whether or not we need to stay home and take care of the little one. But now with technologies like this, she can be there in person without being there in person, right? And we can alternate and take place. It does, in my mind, have a very strong position in our things going forward, and especially with the 3D 4K capabilities, we're able to record now our surgeries in 3D. In the metaverse platform, we can actually play them back in 3D. So you can really appreciate the depth for educational purposes, teaching people what capsulorhexis is, doing advanced techniques like sutured IOLs or Yamanis. It really gives them an appreciation for the depth and the technique.
Is there a way to do hybrid meetings where, if you can't show up for a meeting? I'm just wondering if there, in the future, actually, for a lot of big meetings is sort of some form of hybrid format where some people can show up in person and others want to be involved without showing up. And I don't know if
this may or may not be happening for ASCRS 2023, where at the end of it there will be a metaverse component of it. So I've been working with Steve Spears on that frontier.
I think they just sent out a mail as well recently about the same.
Oh, for the digital day, yeah. So with the Digital Ophthalmic Society, there's a new subspecialty day dedicated towards, again, stuff like this, digital technologies, whether it be telehealth, telemedicine, AI, machine learning, EMR, diagnostics, what have you. Especially as we broach this new frontier and need things to start working together, we needed a platform. Which really kind of set the stage and set this gold standard for organizing these technologies. Because if they all exist in their own silos, they're never going to work together well, and it's not going to benefit our patients, and it's not going to benefit us, right? So
Eric, I'll give you some advice, free advice from someone who knows a lot less about this stuff than you do. I think this is fascinating technology, and I would say just put together like a 1 hour or 1.5 hour educational program using this platform with content from Ted Lang, and you need a better picture for Ted Lang, John Hovnessian and Kathy McCabe, and just basically use that as your prototype I think that would be a good place to invest to show the power of this. So that then you can actually show that it's reality now as opposed to a concept that could evolve over time.
Oh, absolutely. Thank you. Yeah. We're actively working on just that. Exactly. Perfect. And okay, so we'll keep going here. So now let's play this video. This is a very cool one too. The NFT platform here was actually created by a great friend of mine, Stephen Houston. He's a retina surgeon in Orlando. He created the first of its kind surgical exhibit in the metaverse. So it's a museum, if you will, of unique cases and pathologies, some of which can be played back in 3D within the metaverse or 2D if viewed from a computer. So the truly remarkable attribute that the metaverse, NFTs, cryptocurrencies bring is that it's a blank canvas with kind of endless possibilities. To ignore the potential, in my mind, and not harness the positive attributes for, at the very least, the advancement of education within ophthalmology would really be a disservice. So finally, the wonderful, and full circle back to interoperability. I had earlier defined ophthalmology as being akin to Windows 95. And now and we've all laid some groundwork that should help you appreciate that we're actively paving the road ahead. So enter our vision of ophthalmology, Windows 10 version, a machine learning, NFT-backed, interconnected, interoperable system that delegates tasks appropriately, manages user interfaces, communicates with our central framework, and intelligently processes high volumes of data sets with conditional parameters at multiple levels, not just at the one level that we're talking about. Let's do this. In this video, we're about to see some new technology that integrates the biometer via the cloud to the operative digital heads-up display. It performs iris registration to the preoperative data. It can visualize and represent the steep axis, pre-selected incision locations based on the preoperative data, confirm IOL selection, use digital picture manipulation to enhance tissue planes and features, all the while recording, storing, and processing the data. So you're about to see here the iris registration. So we see preoperative scan and intraoperative scan. It now knows the correct alignment and where the degrees of toricity are, and recommended incision locations based on that. This is an interesting one. This is tissue detail mode. So this is our normal view, but we can actually digitally enhance the image. And this is an incomplete capsulorhexis that you can really see now using digital picture manipulation. And lens confirmation, double checking the lens you're putting in is correct based on what you wanted preoperatively, so what the nurse gave you and what was loaded. And here, visualizing the visual axis versus the pupillary axis and the limbal axis. So now we're talking about angle kappa and it actually having some utility, right? We talk about it enough, might as well actually implement some technology that help allow us to align on the visual axis. This is Sean's favorite here, the Aura. Not that he helped invent it or anything, but this is next generation, obviously integrated into the digital microscope. So we're seeing everything without taking our eyes off the screen, and showing us where the toric alignment is, and selecting the best possible lens, all again without taking your eyes off the screen. So the funny thing is, the truth is, we're not far out from this reality that I had painted in the slide before. So my guess is probably within the next 3 to 5 years, we'll have that full picture. It's about time that we leverage the technology to handle the burdens of technology and revisualizing the entire paradigm, therefore kind of returning medicine back to that patient-physician relationship, which is where it belongs, to be honest. The next question I have is for Sean. Maybe I can turn that off. What do you see as the most innovative intraoperable technology being developed right now in medicine to allow us to kind of cross platforms and work with one another? I know that's a challenging.
Sorry. This is a challenging. I think that's the perfect question to punt over to Kuldev, because I helped him on his question. So maybe I could. No, I really. I mean, we at New York Eye and Ear recently adopted Epic, and I see there's some glimmer of interoperability and connection to the patients and being able to export data. But I think all of that we're still very much at the very beginning of this. So I'm not really aware of technologies that are highly interoperable. I think it's a nice nirvana for us. We need to have that because we're collecting an enormous amount of data, which unfortunately we are ending up putting into the system. I remember when I was at UCSF, we did a study with the residents. When you get a new patient, how many clicks you do to enter data in the computer. And I think for a new patient, which was just a regular patient, it was about 52. So at that point, I was really interested to charge not with the DRGs, but click per click, because I think we'll make more money that way. But that being said, I think that interoperability is the next frontier. I think the first one is digitalization, because medicine is so behind that we're still at the point where we're digitizing data, kind of like where Napster was for music about 10 years ago, unfortunately. And I really appreciate the efforts and what's going on in digital health, but I think Kathryn said it. I mean, can we make those avatars a little bit more sexy and more fun? So we're really at the beginning of this, and it's great that we're starting, but I think we're probably 5 to 10 years behind where other places are and other industries are in that space, which is okay because we're focused on public health and medicine and other intents. But I think that right now the goal is to digitize things. Probably in the next 5 years, people will start thinking about interoperability and developing that. And I think there's some really good laws that are coming and regulations about, for example, transparency in billing. So now we have to really be able to tell patients before they come how much you're going to charge them, what is that going to be, and imagine how difficult it is to even figure out what different insurance companies charge patients. So we need to have some interoperability there, because now by act of Congress just this year we have to get up to speed with that. But unfortunately, I think we need to fight the entrenchment that's happening with systems like Epic and some of the other digital health systems that are all thinking about how to digitize their data, but they're not thinking how to export it and make it accessible. But I think that will change probably in about 5 to 10 years going forward. It's really interesting because when we started out about 20 years ago with intraoperative biometry, probably 15 years ago, we had the idea of saying, well, why don't we export the data from the Aura to the cloud? So in fact, 15 years ago, that was probably, and Eric, you would know, but there may have been the first system when we really did cloud-based export of data. And that's when we did a lot of research where we had the data ready, because all of the Aura systems were feeding data, and we could easily report on thousands of cases because we had that data. And that was almost like a decade ago when data and cloud was very different then. So it's interesting. So maybe I should flip the question to you. And since I didn't answer it, but you can answer it for us. Maybe you know of systems that are probably meeting that requirement, because I don't know of any that is highly interoperable, except Gmail and Google, which we can use for other things.
I think that's the big problem. To my knowledge, there are none that are fully interoperable other than internal systems that are occurring in individual silos. Which I think underpins the importance of being able to get ahead of the game and set policy, not necessarily from the governmental level, but from our societal level, what our expectations are from our partners as we move forward in time to benefit not just us, but our patients, which I guess is pretty much a good prelude into what I'm going to talk about in the next couple of slides. But the one consistency that remains in all this is, again, that command prompt, right? Therefore, we need everybody's valuable insight to bring us to the next level. So that's where this Digital Ophthalmic Society has really come into play, and it's sponsored by ASCRS now. So by kind of cultivating group expertise and experience, the society can help each member kind of hone their skills, provide the necessary tools in order to stay one step ahead with the evolving technologies. Right now, we're giving out quarterly advanced topic lectures, protocol development, peer-to-peer engagements, practice education. The Society's purpose is going to aid in the advancement of ophthalmic surgery through the implementation, adoption, and evolution of all the platforms that we were just talking about and mentioning. I love this quote. And then for those of you who watch The Matrix, I leave you with the following. Do not try and bend the spoon. That's impossible. Instead, only try to realize that the truth, there is no spoon. Then you'll see that it's not the spoon that bends, it's only yourself. So ultimately, we must not stay rigid in the face of change. We have to appreciate the time-honored outcomes relative to the era in which they were studied, and finally embrace an evolution to a state where literally just about anything is possible. So thank you, everybody, for allowing me to lay some groundwork here tonight. And we can obviously continue this discussion now, because I think there's some things that we should have talked about, but we did not. And one of those things that I'm going to direct first to Sean is telemedicine and telehealth, because I think that's going to be a really important thing going into the future, even if we don't implement it and utilize it now. Where do you see the utility in the adoption of these home monitoring devices in the incorporation of telehealth and telemedicine and this new ecosystem that we're trying to build?
I think going back to public health, I think things that we can really go back and close the loop on population health. I think this is really important. The other part is really getting back doctoring to the patient. In the old days, we made house calls, and I think then we moved everything into the ASC, into the hospital, into the clinic. I do remember 20 years ago when we invented the first virtual device in ophthalmology, or maybe one of the first ones, which was the perimetry, where we did a fully digital emulation of perimetry. And now we could take perimetry to patients anywhere at zero cost almost of delivery. And that was 20 years ago, and it wasn't that complicated. And we know, I think Kuldev can confirm, probably 50 to 80% of all the undiagnosed glaucoma has pretty significant visual field defects, as some Australian studies have demonstrated. So the problem was that payers then said they will never pay for anything unless the patient takes the test in the office. No diagnostics in the outside. So what's the point? So I think COVID changed all that, and I think now digital technology, software as the devices, and all kinds of other things and gadgets will be going out. I think the FDA is pretty acceptable, has a very good appreciation of their utility, and I think the standards are not as brutal as some of the implantable devices or some of the in-clinic devices. So my guess is telemedicine will become really, really prominent. Monitoring, and actually right now there are reimbursement codes such as RPM, PCM, CCM, RTM, the whole soup that I think ophthalmologists will probably, 99% of us don't know, but in probably 5 years, we will know all of them. Those codes will become very important, because even now, if you think through some of them, you would understand there's higher economics not seeing a patient sometimes than seeing them in your office. And when you combine that with digital technology and going back to AI, basically high throughput analytics and data science, I think you can really create a perfect fusion for great population health and also great medicine. So I think telemedicine is out there and it's going to be very useful. From an entrepreneurial standpoint, when I talk to people, they don't realize really where the opportunity is, because the waters are very treacherous and not everything makes sense. So I think figuring out where to go, and people like you, Eric, talking about it and distilling the opportunity, because there are things that will be relevant today and things that will be relevant in 10 years. So one has to really be thoughtful about where to invest efforts and where to develop technology.
And I'll just say that I was there when Sean developed the perimeter 20 years ago. I mean, I remember Sean showing it to me. Like,
yeah, with Tom Zimmerman, remember?
Tom Zimmerman, yeah, we were people who aren't even around anymore. And, you know, like, but I can tell you one thing, that one of the fallacies of technology, or like, approaching this from a business standpoint, is this belief that a fee-for-service environment actually encourages change. It can, but it can also limit change. As Sean said, if you don't, if there's no way to get paid, or if there's a disincentive to move out of the office, then that actually can block you. And I think in telemedicine, we've seen this where the UK has kind of been ahead of us, even though they have a nationalized health system. They've actually made more progress in this area than we have in several therapeutic areas. A couple other things. Sean made a very important point about exportability of data. I think Eric touched on that as well. And I think the emphasis right now on has always, up till now, has been in ophthalmology, has been on how many patients, how many data points, and the bigger the better. And so when you hear people talk about big registries, they talk about how many millions or billions of data points they have. But Josh Stein and his group at Kellogg have taken an alternative approach, or a complementary approach, I should say, with the source data set, where it doesn't, I don't know if you need data to be that big to come up with solutions. And I think rather than thinking of big data, we should be thinking of big enough data, because you can have 1/10 or 1/100th of the data some of these large registries have, and still answer really important questions, as long as you can export the data and look at it and work with it and have it be of the quality you need. So
that's high fidelity and clean data, right?
That's right. I mean, big enough or slightly smaller than big, but better quality data. And the last point I was going to make about AI is that a lot of people working in AI, and then again, this is free advice, are doing so many things at once that they're never able to really move one thing really far. And it's almost like a kid in a candy store not being able to decide where they want to really focus their attention. And so I would say to you, Eric, find, of all the things you showed us today, find one thing that you're really passionate about and run as far as you can with that, even if it's just addressing one unmet need that is not necessarily even important to everybody. But if you can, just for proof of concept, do something really big. And the next time you ask the question, where is AI being utilized? We'll say, well, Eric Rosenberg is utilizing it to do this. I mean, he's utilizing it so that when you do strabismus surgery, you don't have to adjust sutures because people see straight, right from the beginning, or whatever it is. I just made that up. I don't know if that's even possible. But so then I think that moves the whole field forward if you can do that one big thing.
I agree. Thank you.
Fabulous.
And
we do have to so last 1 minute, whatever you want to say, Eric.
Oh, no. I was gonna let Kathy take the reins, especially with I'm actually very interested in her applications for the diagnosis of keratoconus, and it's something that's always been very challenging and something I deal with in my day-to-day. So having an AI-backed algorithm for screening at younger ages, and my question was going to be oriented towards your research because I follow it very closely. I think it's going to be really unbelievably helpful, especially with a diagnosis that isn't as clear-cut as maybe some of the others, like glaucoma, where, like you said, we don't really know what glaucoma is. What is keratoconus? When does it become keratoconus? Who's at risk and all these other factors. It's, I kind of turn it over to you where you see the technology of AI being implemented and how that's going to be incorporated. Oh, you're on mute. Sorry, Kathy.
Sorry. Thank you. Yeah, I think the needle has to be moved. I mean, I think there's going to have to be, especially with keratoconus, we're going to have to really involve, maybe the American Academy of Pediatrics. And it's sort of like, how do we decide that, that everyone should be screened for colon cancer when they're 45, and so there has to be some sort of guideline that is understood by, pediatricians and maybe the Academy of Ophthalmology and maybe the National Keratoconus Foundation, that we have to be screening for this. So I think that there's a bigger step in that direction that needs to happen, and then the kind of move downwards into like getting the screening out there. I mean, maybe there'll be a kiosk in the mall or something too, or in a school, or just there. I think we have to think outside the box, because to think that every single person's going to go see an eye care professional, especially, it's not possible. I mean, they're just not enough of us. And for our populations, and as you mentioned, the old elderly population, and just a shortage of eye care professionals for that population too. It's just we have to move the needle in the direction in this way. So we have to think differently.
Definitely agree, and that's the scary part too for me, and I guess some of the others, newbies, if you will. When you're inundated with so many different things, it's hard, like Kuldev was saying, it's hard to just focus on that one thing and then being able to advance the needle. I fear that without early adoption of protocols and standards and everything, we're going to be chasing our tail for the next 20 to 30 years, which is why I think that platforms like the Digital Ophthalmic Society are going to be very important moving into the future, because we're not going to be able to move, or we'll move the needle in a silo for one particular thing, and won't be able to address it for gross populations. And then we're still going to be shorthanded and continuously chasing our tails around. So that has me excited that these platforms are starting to exist, and they're being led by the experts in the field like you guys. So I'm eternally appreciative and excited to work with you going into the bright future as we design it, I guess.
Congratulations! Wow, that was an incredible presentation, and everyone on the Rising Stars, all the celebrity panelists, you all gave so many great pearls and thoughts. It's super fun learning from you all. So I just want to congratulate you all for being part of this and helping us all learn so much.
Yeah, thank you, Bill. Thanks.
Thank you all. It's great experience.
At the end, I really have to say, Eric, some of those topics that you brought about have really changed the way that the audience is going to think from now onwards. Believe me, we all actually learned a lot from your topics as well. In fact, we were fascinated by the inclusion of metaverse and the whole 3D experience that we are going to all see more of, not just from educational standpoint, but from a training standpoint as well. So all of this is going to impact in a big way going forward. I know some people in Mexico who are already doing a lot more 3D training across borders. And so this is going to really have its impact in the future for sure. And this is probably going to be our most watched rerun of all seasons, because a lot of people, as I told you in the beginning, are unaware of the tip of the iceberg that we are seeing in digital ophthalmology. So keeping that in mind, thank you folks, for everybody for being here. Celebrity panelists, Sean, Kuldev, Kathryn, I could not thank you more for being here. I'm looking forward to actually being with you guys very soon again. So hopefully in May this year, next year, we should definitely catch up there. But awesome. Eric, thank you very much for your, you have done such a swell job with the presentation, and the conversation we could have gone on for an hour, to be really honest, and it would still be less for a topic like this. We should talk more about these topics, because they are the future. They bring us all together and, makes us one community. That is what we are. So thank you so much, guys. Thank you, audience members, for watching. Remember, Rising Stars, risingeyestars.com is the website. Please watch it. And Rising Stars in Ophthalmology, Facebook, YouTube channels. Take care.
Thank you. Happy holidays, everyone.
Take care. Thank you.
Yeah. Happy holidays.
Bye.
Thank you so much.
Thank you.
Happy holidays.
Bye.
Guys.